This time we are going to do something that would be useful for portrait photographers. So let's get into it. I'm going to do a search of this term here so that we can get the sample code. So go to search engine and type Mathematica, followed by this, recover head poses by reducing dimension. And you will see this one. Go there. Okay, so let me show you what it does. When you take many pictures of the same model, now you can arrange them in the coherence of the pose. That is, the similar ones are together, like this top view going into the bottom view, or the center view going into the side view, like this. So we will be able to do this, but I don't have a sample picture of a same model taken from all these angles. So instead, we are going to generate the data. So I'd like to show you how to do that. So first, please copy this code here and go here, and then go to the bottom of your code and then have a new cell that is have this line here, and then paste it, and then go shift enter. Before we move on, I'd like to show you what each one is doing here. The first line is generating a point on a semicircle. So here's a circle of radius at radius 0.8, centered at 0, 0, but not the full circle, but one that goes from the pi to 2 pi. So this is a half a circle, 180 degrees to 360 degrees. So we have a circle of this point here, and from that we are going to pick 50 points out of it. We didn't use any random seed, so your answer will be different from mine. But I'd like to show you where they are. The CCs are the points on a circle. So if I do point, no, let's do this here. Graphics, open bracket. Oh, it's giving me errors. Okay. But nonetheless, let's we can run it again. Sometimes it works, sometimes it doesn't. Maybe it worked. Let's see. Graphics, and then we do points. Then open bracket, and then type CC, close bracket, and then do shift enter. Oh, it's not working again. Let me try 1 + 1. That works, but this is not working. Maybe it didn't work. Okay, let's run this again, but let's this time run one line at a time so that we can see where it's going wrong. So I will copy this line, copy it, and go to the bottom. I will get rid of this guy and go to the bottom, click and paste it, shift enter. It seems like that one worked, so this should work now. If I do shift enter, oh, it's not showing it. Okay, now let's do the second part. If I copy the second line and go to the bottom, click and paste and shift enter, it ran too. Okay, so far so good. And then if I go here, the third one, go to the bottom, click, you see that faint line, paste and run it. VP also worked here. Okay, then object, maybe this is giving us a hard time. Copy and go here and paste, shift enter, and then we got this. These are the Beethoven's OBJ. Let's see, you will see. It looks like this. Beethoven's bust. I will close this guy. It's taking a long time trying to show. This is 3D object, and it has to not just show the image here, but it has to load the entire data so that we can move it around. You will see what I mean when it loads. In the meantime, let's prepare for the future. Going to this poses here. Okay, copy this, copy the line, go down, go to the bottom of your notebook, click, and then paste. I will not run it yet. And then prepare for the next one. We did poses. This image here is not just single line. I got to go from this image to the end of it here, semicolon. Okay, copy, and then go here and paste. Okay, so we prepared for the future, and we are waiting for this object to show up. Okay, it's still going, so I will prepare further for the future. I will copy this code one more time, but I will now load into the desktop version of it. So here it is. Okay, I'm going to run it here. It runs much chirpier. Except this has to load this example data. So let it go. let it work while we check the other guy here. It's still loading. Okay, it's a waiting game now. While we are waiting for both versions, I'm going to prepare for the future by going for the next part of the code. So this is not the, this is just to see the sample of which directions we have it. So let's just click here, copy it, and I will put on the cloud here. That will be our next step of doing it. While at it, I'm going to go to the desktop version and prepare for the future too. Okay, so that was the next code. And then here, we do the dimension reduction part. So click here, the code was copied. So I will go to the bottom and paste it here. And also on the desktop version, I will click the bottom to get a new cell and paste it there. Okay, now this is the last one. We are going to visualize it with using this graphics here. Copied it. So I will go to the bottom of the notebook, paste it. The same for the desktop version. I will go to the bottom, click, and then paste it. So I'm ready. Whoever finishes first, I will use that to explain how this works. Okay, the desktop version finished first, so I will use this to explain. Here, the CC is just picking a random points on a circle. So I wanted to show you this here. The circle going from here to here. I can use graphics to show you. So graphics, and then if I do point, and then put those points there. Actually, I didn't mean that. I meant to do circle. I just copied and pasted into here. Then you will see it's a semicircle. That's what I wanted to show you. I will delete this here. But you're doing random points out of it. So you got CC. What are these variable the numbers inside this variable CC? These are these points here. By itself is meaningless. So I'm going to do graphics. And then open bracket. And then I do point. Open bracket. And I got to close the point. And then I got to close the graphics. So I did this here. Make sure that you're capitalizing each letter, each word. And then when I do this here, the semicircle, it randomly picked however many points, 50 points. There are 50 points in here. So that's how the CC worked there. Then PP is going to pick these, this would be the Y coordinate. No, this would be, it's picking one of them using 2. So this is the X coordinate. And this is the Y coordinate of the CC. And actually, I'm not sure how this is doing here, but what does PP does is, let's see. If I do PP here, I see that it is a three-dimensional coordinate. So what are they? It's hard to see by looking at the number. So what you could do is do a graphics 3D. I don't see it yet. Fix 3. Here we go. I got this. Open bracket, and then you got to say point again. Point bracket. Go here. You got to close it, and you got to close it, and here. So this is a stage lighting or the camera. So this is from point of view from where the camera will look at the object. So this is how they're going to randomly select a few out of it. You see, random sample, VP. So now if I put VP here instead of PP, it is just randomly selected how many? Let me open this a little bit. It picked 60 out of it. So I have a lot here, but if I do P, what is it? Sorry, I forgot. VP. VP stands for viewpoint, probably. So when I do Shift Enter, I will have 60 of them. So it's randomly selected. They seem to be scattered, but if I do this here, you see they're on that semicircle that I showed you before. So you will look at the object from these points. So they just didn't want to have too many of them, so they randomly selected. That's what it is. Okay, so from this viewpoint, you're going to look at the object. What is the object? That's what I wanted to show you, and it's taking time. I will show you here. Object is this. And then you can turn it around and see it. That's why it's taking a long time, because it's trying to load not just a picture of it, but 3D details of it. But why does it take so long? I think it expired already. So let me do it here. Shift Enter. I will get the object one more time. And then, you see, it all expired. It lost all these numbers here. The online session. Oh, now it finally showed here. So, amazing. This is a web page, but I can do this. Maybe I can do the whole thing again. So, let's see. Run this whole thing again. Oh, it produced the graphics also. Okay, hopefully it will not give errors this time. And I don't have to run this line by line again. But while waiting, I will show you here. Okay, so this is the object seen from all these viewpoints. So that's what they're trying to do. And then what you do is that you get the poses of that object I just showed you. So you're looking at the object from all the viewpoints that you had here. So you will be seeing it. Earlier I was showing you by turning it around, the object. I was rudely pushing ViewPoints around to show you from all these directions here. But now Mathematica will do it by itself by choosing different points, viewpoints. And then you will see a whole bunch of ViewPoints seen from different angles showing up. Here we go. But each one still can be rotated. But the point is, we don't want to do it by hand. We see all of them can be turned into any direction we want. But the whole idea is we don't want to do this by hand because we may not be completely random. So what we do is that we let the computer do it. And you just saw it, what they look like. But as you saw, there are 3D objects, not images here. So now by rasterizing, you turn them into images. So let me show you what the images look like. When you see the images, there we go. These don't move anymore. These are good old images. So when you are doing this with your own pictures, you would skip all this beginning part and go straight to images. And you would have to say images equal to curly bracket, open, close, and you got to put your own images in it, separate by comma. Once you got those images, then you are at the same starting point as this and start from there. In fact, yeah, that's where you start. Okay, so we are done up to here. Did they finish up to there? Oh, seems like they also finished there too. Okay, without errors this time. So I will get rid of this codes that I did. PP, and I explained the whole thing already, so I will delete them. Be careful not to delete the whole thing here. Okay, we did poses too, and images too, and we got to do random sample. So the image, we are going to see only 10 of them. There we go. Okay, we understand. And then now we are going to do image, the dimension reduce. This is an advanced concept that I cannot explain. So we just let Mathematica do it for us. And then after that, we are going to run this. This is also, but you've seen what graphics does. It produces graphs. But we are going to arrange it in such way that their positions are going to be related. So while it's running, I will continue explaining here. So it's the same thing. So we see 10 of them. These are the ones. You see they look different because it was random sequence. Some of them, it was chosen randomly. So it's the same good old Beethoven, but it is seen from different angles. So I'm going to run this and see punch them to the conclusion by running the graphics. Okay, I got it. So this is the picture I got. It's different from what we had before. So these are the positions, the angles are related. So this top is here, and then your angle is coming down, and turning left and right is also just basically adjacent ones are related. Now here, it also shows differently. The reason you are seeing different ones in different runs is because you have different images. Why do you have different images? Because you have different random samples. So if you don't want to have this kind of difference here, you just have to say seed random. So now it doesn't matter what number you give. So here, anything that starts with seed random will produce the same result now. So if I go here and run here up to there, why don't I run the whole thing? Okay, and then I'm going to say seed random 55 on mine too. I will go to the top here, click, and then I do enter, and then say seed random 55. No, I thought I copied it. Seed random 55. Okay, so I will run these guys too. Here, run, and I didn't mean to click that. Here, click, and go here, click. Okay, so this time they're both running So when they are done running, this time they should produce the same images because the seed controlled what kind of sequence they would get, and we would have gotten the same numbers. Let's check. Let's wait and check. Okay, the desktop finished already, and this is the kind of picture I got this way. And then this also would foretell what kind of results we'll get. Look at that. They are exactly the same sequence, you see, because we fixed the random seed random. So when you do a large project and that involves a lot of just even one random number, you and your colleagues may produce different results. And then some may be good and some may not be, but sometimes reproducing the same thing supposedly would cause the error, and you want to have the error reproduced to fix it. If you didn't use seed random, then you cannot reproduce that error anymore, and you cannot find out what went wrong. So even the processes that use random numbers, it's customary to do seed random so that you can reproduce, especially when things go wrong. For a demo, especially when things go right, we want to keep it so that we can show the right one. Okay, now let's make sure that the result we get is the same. Interesting. They don't look the same. Okay, this is beyond me. I'm not sure why it is so. In this case, it's kind of crude picture of Beethoven's bust being digitized from different angles. But if you do this with a picture of a model, it doesn't have to be a person. This could be a car or whatever that you take from different angles and then put into this tree. You may get a very interesting composite picture out of them.